Okay, for example number 6, we're solving applied problems involving hyperbolas. The design layout of a cooling tower is shown in figure 11. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At their closest, the sides of the tower are 60 meters apart. And so we can see here for where it's 60 meters apart, it's 79.6 meters. Now we want to find the equation of the hyperbola that models the sides of the cooling tower. Assume at the center of the hyperbola, indicated by the intersection of the dashed perpendicular lines in the figure, is the origin of the coordinate plane. And we're going to round the final values to 4 decimal places. Now for step number 1, we're going to assume the center of the tower is at the origin. So we can use the standard form of the horizontal hyperbola centered at the origin, which is x squared over a squared minus y squared over b squared, which is equal to 1. Where the branches of the hyperbola form the sides of the cooling tower. Number 2, we must find the values of a squared and b squared to complete the model. First, we find a squared. Recall the length of the transverse axis of the hyperbola is 2a. This length is represented by the distance where the sides are closest, which is given as 60 meters. So 2a is equal to 60. Therefore, a is equal to 60. And then when we square both sides, a squared is equal to 900. Step 3, to solve for b squared, we need to substitute for x and y in our equation using a known point. To do this, we can use the dimensions of the tower to find the same point xy that lies on the hyperbola. We will use the top right corner of the tower to represent that point. Since the y-axis bisects the tower, our x value can be represented by the radius at the top, or 36 meters. The y value is represented by the distance from the origin to the top, which is given as 79.6 meters. So therefore, we have x squared over a squared minus y squared over b squared is equal to 1. And so we subtract x squared over a squared on both sides. And then we're going to multiply everything by a negative, so we get y squared over b squared, which is equal to x squared over a squared minus 1. So now rewriting this, we have x squared over a squared minus 1, which was what on the right side. We're setting it equal to what we have on the left side, which is y squared over b squared. So what we want to do is we want to solve for y squared. In order to do that, we're going to multiply both sides by b squared. If you multiply both sides by b squared, what's left is y squared, which is equal to b squared times x squared over a squared minus 1. Now again, we're trying to solve for b squared, so we're going to divide both sides by x squared over a squared minus 1. And now we're going to fill in what we got for y, what we have for x, and what we have for a. So again, we're using the point that we just determined where x is 36 and y is 79.6. Okay? And then we're going to plug it in to find out what b is. So we get 79.6 squared, and we're going to divide that by 36 squared over 900 minus 1. And so b squared is going to be approximately 14,400.3636. And so the sides of the tower can be modeled by the hyperbolic equation x squared over 900 minus y squared over 14,400.3636 equals 1. Or we can say that x squared over 30 squared minus y squared over 120.0015 squared is equal to 1.